So we know that volume equals length times width times height. Since we know it's a square base, we know that these two are the same. So we have volume equals x squared times y.
And in order to find the relationship between the base and the height, we need to know the surface area. But we already know the value of the surface area. So the surface area equals x squared plus 4 times x times y, which is equal to 1200. And then we need to get rid of one variable because we have like two variables. So we're gonna write y in terms of x. So 1200 equals x squared plus 4xy, and then y equals 1200 minus x squared over 4x. And then we plug that in to the volume equation.
And we get 300x minus x cubed over 4. So in order to find the critical numbers of this equation, we need to find b prime of x. So we differentiate this, and we get 300 minus 3x squared over 4. And so in order to find the critical numbers, we have to set that equal to 0. So we set that equal to 0, and we get that x equals 20. So x equals 20 is a critical number.
So we made a sign chart in order to see whether there's a maximum. So between 0 and 20, the derivative of v was positive, and then after x equals 20, it was negative. So the sign change indicates that there's a maximum at x equals 20.
So in order to find the volume, we need to find the values of x and y. So in order to find y, we plugged in our x value, which is 20, into the equation for y. So we got y equals 10. And since we know that volume equals x squared times y, we get x, which is 20 squared, times y, which is 10. We get 4,000 centimeters cubed.